Mic test 1 to 3. Okay, I'm live. Okay, good evening, folks. So I'm back where we left. We'll be starting with day 9, Advent of Code. Let's start with day 9, part 1. You slide down the fire pole in the corner of the playground and land in the North Pole. Base movie theater. This is irrelevant. You are given some coordinates, and these coordinates look like they are marked on a grid. So hashtag are the red tiles and others are marked by dot. The above arrangement of red tiles would look like this. You can choose any two red tiles as the opposite corners of your rectangle. Your goal is to find the largest rectangle possible. Choose any two sides, any two tiles as the opposite corners of the rectangle and find out this particular region. What do we need to do with that? Largest rectangle you can make as an area, so we need to find the pairs of opposite corners which will create a rectangle with largest area. The input looks small to use a brute force approach of trying out all possible pairs. Yeah, this list also looks small. Find out the area. What we can do is simply find out the difference between the x coordinates, that would be the length, and difference between the y coordinates, that would be the breadth of the rectangle. Let's use Python for this. Cool. So we got these coordinates as the input. So lines, this is, let's do file IO in one read mode dot read. Let's print lines. We want horizontal splitting. Let's run the code here. Python 3 main1.py. Okay, most probably we got a empty line at the end, so let's filter that. Let's see what we can do. This is a list of line for line in this if length of line is greater than 0. I don't think so that's correct. So what we need to do is we need to split this on a new line. Cool. So we got the coordinates. Let's go over each of them. So these are xy in lines dot split. No, these should be for line in lines, and xy should be line dot split on a comma. And let's also map these two integers, and let's see if we are able to pass them correctly. Print xy. Cool. So once this is done, ideally we don't need to do this. Let's store the coordinates in a list as a list, and let's add them. Add xy. Let's do I in range, length of chords, and for j in range, length of chords. We don't need to worry about ordered or unordered, because since we are only considering the difference between x and y coordinates, they would yield the same result irrespective of the order. So the area would be, is there a absolute function in Python? Import math. Why is this complaining? Append. And this should be math dot absolute. I don't think we have that, but let's see. So x1 y1 is cods of I, x2 y2 is cods of j, and answer is max of answer comma x1 minus x2 dot absolute plus 1, and this whole thing multiplied by the y coordinate, which is the breadth, y1 minus y2 dot absolute Python apps function. Let's try this. Okay, why is this complaining? Do we need one more parenthesis? What's the issue here? Let's do it in a simple way. So if answer is less than best, answer is best, and answer is 0. What am I missing here? If answer is wait, so this should be like this, and cool. Let's try this. Answer is 50 for the sample case. Yep. So the answer is 50. Let's try it on the larger input. Okay, the answer is 4733. Let's try this. Cool. Let's move on to part 2, but let me also commit this first. So yeah, cool. Solved day 9 part 1 in Python. Okay, let's see what is asked in part 2. The elves, just remember, they can only switch out tiles that are red or green. So a rectangle can only include red or green tiles in your list. Every red tile is connected to the red tile before and after it by a straight line of green tiles. The list wraps, so the first red tile is also connected to the last red tile. Tiles are adjacent in your list, will always be on either the same row or the same column. Using the example as before, the tiles marked X would be green. So this was the example. Every red tile is connected to the red tile before and after it by a straight line of green tiles. So before and after in what sense? In the sequence or in the um, row or column? List tabs. So the first red tile is also connected to the last red tile. Tiles are that are adjacent in a list. Okay. Tiles that are adjacent in a list will always be on the either the same row or the same column. Okay. This is already given as a constraint in the question. Using the same example as before, the tiles map text would be like this. Understood. All of the tiles inside of this loop of red and gray tiles are also green. Okay. I'm hoping this is a large cycle that is created. Mm, yeah, and they've also mentioned that the first red tile is also connected to the last red tile. So that means it will not be a multiple connected components, but a single cycle which connects to each others. All of the tiles inside the loop of red and gray tiles also green. Fine. You can ignore the remaining tiles. The rectangle you choose still must have red tiles in opposite corners, but any other tiles it includes must now be red or green. This significantly limits your options. For example, you could make a rectangle out of red and green tiles with an area of 15 between these two coordinates. Yeah, correct. Or you could make a thin rectangle with an area of 3 between these two. The largest rectangle you can make in this example using only red and green tiles has an area of 24. Okay. Using two red tiles as opposite corners, what is the... Okay, understood. The issue here is the coordinates are too large, so we can't simply create a grid out of these coordinates. I need to think of some clever way to find out whether all the coordinates, I mean, for any pair of coordinates, uh, does that region completely lie in a uh, this larger component? Okay, let me think of this. Hmm. Visualizing this would also be difficult. Let me think on this first. Maybe I'll spend some time thinking on this, and if it is too difficult to figure out, then I'll move on to the part one of next day. Let's reset this. we are given a grid, and in this there are multiple so this is like one large cycle. So let's say this is connected like this, and again this part. I'm considering this complex example. So in this case, let's say I select this one, and these two coordinates I select to find out the area between them. Then they are not valid because there is this region which lies outside of the area that is selected. But if I select these two, then this area is valid. So how do I figure out whether the area between any two pairs is valid or not? Instead of trying out all the pairs, what I can do is um, I can traverse three coordinates in a row. So let's say even in these examples, the answer always, not always, but this particular rectangle marked with O had like three corners sequentially in the input. So let's say I want to select this larger one, then I can traverse them like this. And once they are selected, how do I find out? Again, the question lies the same. Once this is selected, I only need to know whether this particular line is valid. Let's say these three were selected. Obviously, they are not valid. And how do I check that? I'll probably spend next 5 minutes on this and move on to the next problem if I don't see any hint. This particular case is also good one. So this lies outside the uh, larger area. And how do I ignore this particular tuple? Question. Okay, I don't have any idea on this right now. Let's move on to the next problem and we'll get back to this afterwards. Okay. Just across the hall, you find a large factory. Fortunately, the elves here have plenty of time to decorate. Unfortunately, it's because the factory machines are all offline and none of the elves can figure out initialization procedure. The elves do have the manual for machines, but this section detailing the initialization procedure was written by someone. All that remains of the manual are some indicator light diagrams, button wiring schematics, and voltage requirement for each machine. For example, this is the input. The manual describes one machine per line. Each line contains a single indicator light diagram. This is the diagram, and one or more button wiring schematics in parentheses. Voltage requirements in curly braces. So these are voltage requirements, and these are uh, button wiring schematics. To start a machine, its indicator lights must match those in the diagram where dot means off and hashtag means on. The machine has the number of indicator lights shown, but its indicator lights are all initially off. XYZ.